Okay, so now what we're looking at is we're matching A, B, C, D to the graphs down here. So notice this is an exponential function. A is the multiplier, what's multiplied in front of the exponential function, e to the x minus h. This h right here is, the formula is x minus h. So when we look at the h on here, we have to remember that it's being subtracted. So this first one, A is positive. So if there's a positive number in front of it, that means that the graph is going to be increasing. It's going to be a growth. So it's either going to be this one or the last one. And where h is positive, so that would be x minus h, which does mean that it's going in the positive direction. So this would be A. And then B, A is positive, h is negative. So if h was negative, this would be x minus a negative, which would ultimately be positive, which means that it would go to the left. So that one would be B. C, A is negative, so it's going to be a decay. It's going to look like this, not necessarily a decay. It's the inverse there. And H is positive, so H is positive, that means it's going to be shifted to the right. So this one is C. And A is negative, H is negative, that one is D. This one, we are going to be stating the asymptote, domain, range, and transformations for each function. So it might be easiest to just start with the transformations to kind of notice what's happening there. So we have this x minus 3, so it's a minus a positive 3, which means it's going to go in the right direction. So it's going to be translated right 3 units. And then it has this plus 5 being added to the whole thing, so that means it's going to then also be translated up 5. Now when we look at the domain and range, the domain of a log function, if it were the parent function, just log base 2 of x, then there would be the domain would go from 0 to infinity, but where this has been shifted right 3 units, now the domain goes from 3 to infinity. And the range, since this is a log function, we know that the range of a log function is always all there is. So double barred R. Then if we look at this domain tells us then that there's an asymptote at x equals 3, because 3 is the boundary of where the values go. Next one, since we have this negative x, that negative x makes it reflect across the y-axis. Just write that down. Reflect on the y-axis. And then the negative 3 makes it shift down. So I'm going to put that it's going to go down 3 units. And then when we look at the domain, because it's been reflected across the y-axis, that means that instead of going from 0 to infinity, now the domain of it goes from negative infinity to 0. And the range is still all real numbers. And the asymptote will be at x equals 0. The asymptote didn't change even though the reflection of the graph did. Okay, letter C with that negative out in front. Now that makes it reflect across the x-axis. And we have a couple other things going on here. So that positive 2 being added to the x, that's going to make it shift to the left 2 units. the positive 1 makes it go up 1 unit. Okay, the domain, since it was reflected across the x-axis, that was be shifted like up and down, it would still be from 0 to infinity, but where it has been shifted left to, now the domain will go from -2 to infinity. The range is still going to be all reals, because it is a log function, and the domain of all log functions are all reals. And then there will be an asymptote at x equals -2. You know it's a vertical asymptote because the domain is restricted. The domain only goes from -2 to infinity. That's the boundary. So it tells you that that's the asymptote. The vertical line at x equals -2. Looking at number 15, I can expand and condense logarithms. So we're going to expand the following logarithm expression. Notice here we have 16 times an x to the 5th divided by y squared. So the division is happening first. So we're going to split that apart to log base 4 of 16x to the 5th minus log, I forgot to put the base over here, log base 4 of y squared. Now we notice there's multiplication going on here, so we're going to split that apart with addition. So we have log base 4 of 16, and that one is pretty much done. I can't expand that anymore. Plus, now I would have, I'm going to do this in one step. I have log base 4 of x to the 5th, but I'm going to bring that power out in front as part of the expansion. So it's 5 log base 4 of just x. And then I'm going to bring this power of 2 out in front. So it's log base 4 of y. Number 16 also has some division going on first. So we're going to split that apart into log of 5 minus log of 3x squared. The 3x squared can be expanded. So we still have this log base 5, or log of 5 minus. Now this is where it gets a little tricky because this whole thing is being subtracted. So we have to put this in parentheses. So it's log of 3 plus log of x squared. Now if I distribute that negative, my final answer would be log of 5 minus log of 3 minus, and then I'm also going to bring this power out in front and expand that to 2 log of x. Number 17, I have some division going on and some multiplication and some powers. So first I'm going to break apart the division. I'm going to start up here so I have a little bit more room. So I have the natural log of 3x squared y minus the natural log of b cubed. Then I have this 3 times x squared times y. I'm going to break those apart, expand those with showing the addition operation. So then I have natural log of 3 plus natural log of x squared. I'm going to bring the 2 out in front. So it's natural log of x plus natural log of y minus, now I need to expand this by bringing the power out in front, 3 natural log of b. Number 18 through 20, we're doing the opposite. We're taking an expansion and we're contracting it together. So this one would be log base 4, and since these are being subtracted, I would take the numbers and divide them. So I have 32 divided by 2. Then you should always simplify if you can. So this simplifies to log base 4 of 16. That's a 4. All right, over here, the operation is addition, so we are going to expand it, showing multiplication. So we have log of 7x, and then there's 2 log of y. That would, if we contracted, it would be log of y squared, and then you show the multiplication with this one, so it's y squared. Here we have addition happening here, and then a subtraction, so these are going to be multiplied together, and then the whole thing's going to be divided by this. So we have the natural log of 5x, and it's being multiplied by this, which is y cubed, and then all of this is going to be divided by the z. Number 21, show how you would use log base 6, or log base 2 of 6 and log base 2 of 18. So we've got to get this in terms of 6 and 18 so that we can use those values. And so, just looking at 6 and 18, I think, well, how can I write a 3 using a 6 and an 18? And that would be 18 divided by 6. So we could write log base 2 of 18 divided by the 6. So that's where the 3 could come from. And then I have to break that apart into log base 2 of 18. And since those numbers are being divided, I then subtract the log base 2 of 6. Then I grab a calculator and I see what log base 2 of 18 is 4.170, and log base 2 of 6 is 2.585. And when you grab a calculator and subtract those values, you get 1.585. Part B, log base 2 of 36. Well, to get that in terms of log base 2 of 6 or log base 2 of 18, I just noticed that if you did 6 times 6, that would be 36. So where that's a multiplication, I would then break that apart using the properties of logs. Log base 2 of 6 plus log base 2 of 6. So what I'm doing is taking 2.585, adding it to 2.585, and my answer is 5.170. Now we're moving on to solving equations. So we're trying to solve for x, or find out what x is equal to. So if we give the x alone, the x is in the exponent here, so first thing I want to try to do is get the same base, so I could then cancel out the bases. I could rewrite 27 in terms of 3, so that would be 3 cubed is 27, and then I still have that x there, and that is equal to the 3 to the power of 2x plus 1. Now, since they have the same base and they're equal to each other, I know that their powers are then equal, so I could write that as an equation and solve it. So I get 2x plus 1 equals 3x. If I minus the 2x from each side, I get x equals 1. Now the only thing I need to check is to see if that will give us any undefined